All right, so I have a few slides to share about just some early work we're doing around security assessment on ARM platforms. Um, I don't know if who else is familiar with HSI, which is an existing mechanism that the LVFS makes available, but just to have a few slides to summarize what that is, because that's kind of what was kind of the led to us looking into this topic. I mean, I have a link here to the HSI info, but with the LVFS firmware update tool, you can run it with a security option that will evaluate security mechanisms on your platform, and it will assign an HSI score. It will run on some ARM platforms, but it doesn't do much yet, and so it's an x86 only tool effectively right now. And so it looks at security protection mechanisms that basically are visible from Linux user space. I think there is a driver that it uses to help access some things, but it looks at what you can see from Linux user space. And so the idea is they don't want you to have to, in order to do a security assessment, install a new kernel driver or do invasive things that kind of maybe change the state of your system. They want to run the tool on a production system as it is to assess security state. So that's what HSI is. This is like an example of like what the security scores are. HSI 0 through 5. And then what it looks like when you run it, this is like a run we did on one of our systems. That you run it and it shows you by HSI level the state of different mechanisms. And so that's what a HSI run looks like. And so the question is, like on ARM, and like Piotr was saying, there's this diversity of hardware. How can you do this? I mean, if you look at many of these mechanisms, these are very x86 specific, specific bits for locking your flash, and so on. Some of them are general, TPM related checks, UEFI checks are, would translate to ARM easily enough, but others, wouldn't, various boot guard checks and so on. And so on an ARM platform, I mean, just very quickly, if you look at a CPU, there are basically two isolation areas in the machine. And this one here where you see the kind of orangish beige boxes, that's where Linux UEFI run. And we call that the normal world. It's your normal application workload area. And so there's 3 privilege levels there where your normal world workloads run, hypervisor, etc. Outside of that, at EL3, we have what's called a secure monitor. It's a more privileged firmware component that is there all the time at runtime. And then there's what we call trust zone, which you can see in the purple pink boxes, where you could run other services, other secure services. If you have something that's security sensitive, you want to separate it from your normal application workloads, you have flexibility to run things over there. And so I guess the challenge is for doing security assessment is you can see kind of in some boxes below here that things like fuses, debug state, the life cycle of the system, flash, and so on, other system registers are basically not accessible at all to the normal world. So if you're running like the LVFS tool at EL0, like where I'm showing those application boxes, you simply can't access, even if you had a kernel driver, there's no way to access security state that is privileged and is maybe only accessible by like the secure world. So so that's one problem, is basically the problem of how do you access the state. But secondly, there's no standard on what life cycle state may be. Like, their SOCs typically have some kind of life cycle state they go through as they go through the supply chain, as you go from manufacturing and then eventually into like a secure production mode. But vendors have complete flexibility to do whatever they want as far as designing their own life cycle states. And so it would be difficult to have, one check that could, on any SOC, identify the lifecycle state and look at it. Similarly for Flash, how Flash is protected, we don't dictate that. And so the diversity of what people do, presents a problem if you're trying to assess security. So, but I think this is a problem. And so we've started, a small working group of ARM, with some internal ARM folks as well as other partners to start looking at, okay, what can we do? And so what we're doing, the next few slides is kind of summarizing just what we're doing, in still early stages. And so what we defined as our problem statement is essentially, what are the security properties and capabilities of a system? And so specifically, what is it capable of? So even if, it's capable, but maybe something's not turned on, but the first thing you want to know is, what is the system capable of? What are the properties and capabilities? And then what's the current actual state for a given instantiation and configuration? How do you know that these mechanisms are enabled and in use? So that's the top level questions that we would like to be able to answer. And so, the one thing you could do is the vendor of the system could give you an assurance. So, one answer to this is, oh, well, the vendor will tell you what the mechanisms and capabilities are, and you just have to trust them, which I guess is, not ideal. Another approach could be to have like a lab-based assessment. And so there are things like this. There's this one certification organization called PSA, Platform Security Architecture, that ARM backs, that there's different levels of certification, but part of it could involve a lab evaluating the key security mechanisms and providing a report and a certification. But I guess what we're looking at is, using tools and software to do it. Can you export these properties and capabilities to user space so that you can actually assess, what the current state is? Because one problem with a lab assessment is, even if a platform makes it through a lab assessment, how do you know that my instantiation of it, my instance of it, is in, they're in the correct state? A few other points about under the problem statement. We want something easy to understand. If it's complicated jargon that maybe comes from a silicon vendor, it could be difficult or cryptic. One open question is, can you assign a meaningful score? I mean, one question, like a discussion question, maybe at the end here, I would like, people's thoughts on the HSI scoring. I mean, I think this could be problematic. Like, I think it's potentially useful, but, is it misleading to assign one number? And, can that give you false confidence about the state of a system? But that's one question we have is, can we assign a meaningful number? And then, looking at capabilities as well as current state. We talked about use cases to kind of understand, okay, this is the problem statement, but like, what are scenarios that, where this would be relevant? And this is a partial list of what we came up with. And so, one is you have a laptop that wants to access a sensitive part of a network, and so before providing that access, you want to assess its state. And if it's not in the correct state, if it has like a low score, you could limit its access to certain data. Another one was a scenario someone brought up where they wanted to deploy containers, onto a host system. But before doing that, they wanted to make sure that that host had some required properties and capabilities. And so that's another example of, kind of provisioning scenario where you want to provision something onto a system and you want to know what's on it or what its state is. Another one, in the case of ARM, given the diversity of platforms, if someone wants to evaluate an ARM system, kind of like Piotr was, talking about, how can you know what's there, given the diversity of it, and that, it'd be very difficult to kind of do a security evaluation that's custom for every different ARM SoC. An IT department might want to evaluate their fleet of devices, identify misconfigurations, out-of-date firmware, and then lastly, someone purchasing systems wants to compare. So you have two competing laptops. You want to compare their security robustness, and so a score like HSI or something else could tell you something about their security state. So that's where we're at, and I guess what we're currently doing is, going through, complete set of properties and mechanisms that we think you would want to evaluate. We're prioritizing them, and then we're going to start looking at, okay, how can we, make this visible to a tool. But that's work in progress, and so at this point, I don't have any timeline or specifics of what our outcome is going to be, but I just wanted to share this work in progress that we're doing, and yeah, it would be I guess that was my last slide. So I'd be curious, I guess, one, if you have any questions, and then also curious about are there other use cases that you guys see or can think of that would be helpful just to understand, like where would you find a security assessment useful, and then also would be curious about anybody's takes on HSI and how useful it is in the real world.